Hello everybody, and welcome to our final assignment for additive manufacturing. For this final project, my partner Philip and I, we have chosen the Yu-Gi-Oh! Dual Disc. For our reference image, as you can see here on the left, this is what the model that we based our project on. The designing of the Dual Disc comes with many different steps and procedures. As you can see here on the right, these are some of the key features that we focused on for this project, which include 2 blades, a dome, graveyard, deck housing, and an LCD display. The playing fields where the cards are placed will be where the 2 blades are. The dome and the graveyard are going to be part of 2 different designs of a base as well as the dome, whereas the LCD display will also be integrated into the overall design.
The size of a standard Yu-Gi-Oh card is 63 millimeters by 88 millimeters. This being the only reliable measurement gave us a lot of designing freedom when considering how to proceed with the dual disc. A dual disc requires 5 monster zones and 5 spell and trap card zones for the game of dual monsters. Separating the blades into 2 sections, one containing 2 cards and another containing 3 cards, provided enough space for the game. Adding a motor would have been an ideal situation to move the 2 card slot into a standby position when no game is currently taking place. Monster zones require monsters to be played in either attack position, being vertically, or in defense position, being horizontally. Making enough room on each monster zone was a key factor in designing the blades. Spell and trap card zones, however, only require the card to be vertically in a slot in the center of each blade under the monster card zones. The design we decided to go with is as follows. We have the 2 card slot and the 3 card slot, each with having a slit for spell and trap cards in the bottom of the blade.
The dome. The dome is the top part of the dual disc, which is located at the very top of the cylinder. This area requires the LCD to display remaining life points, which is part of the game rules. In here requires the housing to place the deck inside, in addition to the graveyard deck location as well. Both of those also are oriented based on the size of the cards, with enough room to place multiple, where a deck holds approximately 50 cards. The hollow cylinder underneath the dome, which will be part of the base cylinder as well too, where it will be strapped to the user's arm, also has enough space to contain the circuitry, which will be for the wiring, and the Raspberry Pi, which we will get to in a further slide. The dome design. As you can see here in the 2 images, this is where the main design of the dual disc will be shown. On the left side is going to be where you will find the housing for the cards of the graveyard as well as the main deck, in addition to the hollow cylinder where all the circuitry and Raspberry Pi will be found. As you can see here on the right image, this is the very top part of the design for the dual disc. Here it will house the LCD display in addition to the buttons.
The blade attachment. The blade attachment will act as a linkage between the blades and the cylinder, holding the entire project together. The blade attachment gave a few problems in the designing phase until we ultimately came together to design the final product. It is a solid piece with 4 pins that will connect to holes in the rear of each blade, and then the curved end of the attachment will connect to the cylinder bottom, creating the entire dual disc completed. Blade attachment design. This being the prototype design before a motor was added to move the 2 card slot to the standby position, this design was created when the 2 blades are connected to hold them in place while they're being attached to the cylinder bottom. This was the final design we came up with before adding a motor.
Printer settings used. For the printer settings, we used an Ender 3 3D printer. For the print of this design, in order to go into Cura to make sure everything could print properly, we did have to scale down our design by 50%. This was due to our design as, for example, the 3-carded arm. The blade was a little longer than the actual print bed itself, so for the purposes of being able to print with an estimated time in addition to meters and grams used of PLA. The 50% scale down model was able to give us a more accurate design and result. A few key printer settings that were used in this print were the infill density was about 20%. We wanted to ensure that the design was not too heavy for the arm, but we also wanted to make sure that it was strong enough to hold up the structure itself. For the material, again, we used PLA as the most affordable design, with the printer extruder temperatures at 200 degrees and the build plate temperature at 65. The rest of the options we chose were mainly default, other than the support, which sometimes were turned on and sometimes turned off depending on the model that was being printed. Some models were very flat, whereas others did need the support as they had very overhanging angles and features.
Future additions. Ideally, adding a motor to the 2-card slot in order to move it to the standby position, as along with a release switch, would be the ideal addition moving forward to a finalized design. Adding a slot for the field spell cards would also be an ideal design implementation, adding a small slot that would pull out from the 2-card blade. Adding miniature speakers to play sound effects of the life points dropping while also syncing them to the LEDs would be the most ideal case scenario for the most canon effect.
One additional design that we would change would be a proper wrist strap. We unfortunately had to outsource a wrist strap, as you can see in the third image below. This wrist strap was used similar to how a watch wrist strap is. The only thing that would be needed in addition to the yellow parts would be a Velcro that goes through the loops. Something that we would want to have instead of that is something more secure that would ensure that the device stays leveled and not rotating around your arm if more weight is added to one side compared to the other. Thank you again for watching our presentation.
And always remember, believe in the heart of the cards.
Sourced by Davis Palmer.
Oh,
Great.